Alright, it's Edward, back with another video. Alright, so this is problem 59, where I'm trying to find the velocity of the sap coming out of sorry, not the pistons, but the tubes, right? So, let's start with the variables that we're given, right? So, we know the density is 1,400 kilograms over liters. Then we know that we have 2,000 vessels, 2,000 of these, right? Which means that the whole diameter that okay, so we're given this is our diameter, right? 100 micrometers, because that's what the U is actually. So micrometers, so 1 times 10 to the negative 6 meter. Anyways, so we know that we're given this, right? However, that's just the diameter of one of these tubes. So, but there's 2,000 of them, which means that our total diameter actually has to be this times 2,000, because there's 2,000 of these. Okay, and we also know that to find the area of a cylinder, you need pi r squared over 1/4. So now we have to do some conversions, because the equation we're going to be using is Q equals VA. And that is because the volume flow rate is consistent at all points in a tube, right? So we're going to be using Q equals VA, so then, and we want the velocity, we're looking for velocity. Velocity is equal to Q over A, which is the area, correct? Yes, yes it is. So this is the volume flow rate, basically. Oh, sorry, I kind of blanked out. All right, so now we have to do some conversions, right? Because we don't use grams when we're doing anything, right? We always use kilograms. And since this is kind of like the volume, I saw Mr. Tinito, he put something, could ask a question, how do I find the volume? And then honestly, that confused me. I didn't know what to do. I was like, why does it need the volume? But now I understand. Remember when you're converting that 0.1 liters is equal to 0.1 kilograms. That actually made this a lot easier. So then we know that 110 grams is 0.110 kilograms, right? So that's equal to 0.11 liters, or 0.110 liters. Now you could also do it a longer way, which I did at first because I didn't know. Also, we always do things, or at least in this case, in seconds. There's 3,600 seconds in 1 hour, right? All right, so this is kind of our setup, how we're gonna explain things. So we want to know how fast the sap is filling up these tubes, right, in seconds. So this is our primary goal. What's the velocity, or how fast is the sap filling up these tubes? And there's 2,000 of them, right? So we're using this equation. We already established that. So it's really important here. So the micrometers, right? So we have 100 micrometers. So now you got to convert those. What's 100 micrometers? Well, it's 100 times 10 to the negative 6th, which apparently is also equal to 1 times 10 to the negative 4th. So that's our diameter. And while we were converting the grams, right? So for our Q, we got 0.1110 kilograms or liters over 3,600 seconds, which is also equal to 3.056 times 10 to the negative 5th, which is our Q value primarily. So the area total, so it's, it's going to be equal to, you have to have 2,000 in there because we need the total diameter, right? So you're going to have the density, the 2,000, and that's how many tubes we have in that area, right? So you see how we have pi over 4 here, so we're going to move that pi over 4 to the top when we put it in the bottom, so we're going to put the 4 up there. Some basic kind of algebra things. I hope you guys understood me there. So let me just make this a little bit clear real quick. So P density times 2,000 times pi times 1 times 10 to the negative 4th, which is converted, right? Squared. So you're gonna do this, right? Yeah, I mean, you could put 3.056 and 10 to the negative 5th up there if you want, but I just think it's easier to read it like this. I don't know, that's just me. So you do all that, and then you end up getting something around 1.87 millimeters or micrometers. Oh, in the back of the textbook, it's actually 187 nanometers. But I mean, this is how we did it. This is what we got, and I hope this made sense for you guys. Thank you.